Hello everyone, and welcome to today's update on the progress being made on the Orion spacecraft ahead of its first trip to space later this year. Here at Kennedy Space Center, Orion's heat shield was recently attached to the crew module, and just last week it was stacked on top of the service module, marking two significant steps towards its flight test and developing the spacecraft that will eventually send humans to Mars. To talk about the progress being made here and to highlight the upcoming flight test are NASA Administrator Charlie Bolden, Orion Program Manager Mark Geyer, Lockheed Martin's Orion Program Manager Cleon Lacefield, and Kennedy Space Center Director Bob Cabana. For those of you watching on TV or through the web today, we'll take questions from you via social media. You can ask questions using the hashtag AskNASA. And we'll start off with a few opening remarks. So Charlie, if you'd like to start us off.
Thanks very much. Thank you. First of all, thanks very much for everybody coming today. This is a big deal for us. And I was trying to think of how to relate this to something that all of you can wrap your minds around. But as I look out there, the unfortunate thing is that most of you are too young to be able to relate. But how many of you remember ALT? Does that ring a bell? Anybody know what ALT was? How about approach and landing test? Okay, you remember out at Edwards Air Force Base when we took the space shuttle and we dropped it off the 747 because we wanted to make sure it could fly? And it did pretty well. Well, if you want to try to relate what's about to happen in December to something that all of you can relate to, this is sort of like the first of however many flights of ALT that we're going to do with Orion. Right behind me, but in front of you, is a tangible piece of our path to Mars, an Orion spacecraft that's going to travel farther into space than humans have gone for 40 years. Over the past 4 years, NASA's been implementing the NASA Authorization Act of 2010, which was enacted on a broad bipartisan basis. I know you all find that hard to believe, but it actually was enacted on a broad bipartisan basis and reflects agreements between the Congress and the administration on the nation's next steps in space. Exploration Flight Test 1, or EFT-1 as we call it, is a critical part of that strategy and a big step forward on the path to Mars. The test demonstrates how Bob Cabana and the Kennedy Space Center team continue to transform this center into a multi-user facility capable of many different kinds of launches. And it's possibly the most significant human spaceflight milestone this year, pointing toward our return with humans to deep space. Sustained investment in NASA technology advances the agency's exploration capabilities and supports the innovation economy. We need to keep doing that in order to reach an asteroid in Mars and other destinations in the future. As Mark Geyer can tell you about in great detail, Orion's flight test will stress systems critical to safety, including the heat shield, parachutes, avionics, and attitude control. When was the last time you saw a vehicle that could reach a speed? This is a question, okay? This is not rhetorical. When was the last time that you saw a vehicle that could reach a speed of 20,000 miles per hour and a temperature of 4,000 degrees Fahrenheit? When? 1975. That's absolutely right, Apollo-Soyuz. This test is going to show us a lot before Orion carries humans on missions to explore an asteroid and eventually Mars. It gives us the chance to see how this vehicle will perform in the orbital environment as it faces some of the challenges that it will endure on future missions to space. That's incredibly exciting for me, and I couldn't be happier to see the full system integration of Orion proceeding so well. While Orion hardware has been tested extensively on the ground, putting the spacecraft through its paces in space provides data you just can't get here on Earth. Right now, NASA's building on knowledge gained through the International Space Station and more than 50 years of human spaceflight experience, solving difficult challenges that will enable humans to safely explore deep space. What you see here today is a critical part of that strategic work. It's not often you get this close to something that's bound for space. and we look forward to telling you more about Orion and our path to Mars. And since I'm not the detail guy, and I probably couldn't answer the details if you tried me, I have my trusty friend behind me, and I'm going to ask Mark Geyer, the Orion program manager, to step up and make a few remarks before we go on, and a couple more remarks before we take your questions. So, Mark.
Thank you, Charlie, and thanks everybody for coming today. It's a big day for us to actually stack these two elements together. We'll finish now the integrated testing between the two, and then we'll send it off to get fueled and then stacked on the rocket. And as Charlie said, we're going to launch in less than 6 months. So this spacecraft, of course, is the first human exploration spacecraft developed in now over 30 years. It's a big deal, and it's the product of a very dedicated workforce that believes that keeping America first in space exploration is critical. The launch itself, coming up in 6 months, is going to be visible evidence that we are still exploring. But there's other visible pieces that you can see today that show us how we're feeding forward to the next launches. When you come here and see the same event for EM1 and EM2, you would notice it's going to look remarkably similar. And I don't mean just the outer mold line, but actually the guts of the spacecraft. That's because all of these systems that are flying on EFT-1 were designed from the beginning to be human-rated, to be able to fly people on board. And now we're actually not just drawings and PowerPoint, but we actually put it into hardware, assemble it, and now we're going to fly it. We will make some updates. In some cases, we found things we can make lighter, for example, the heat shield, so it was a huge experience for us to build the first one. In some cases, we found ways to make it cheaper on the next one. For example, if you think about the cone up there at the top, the green part, we found a way to make that in fewer parts. So yes, this one could fly people, but now we're going to update it and save money on the next unit. Things like the computer system that's on this bird will be exactly the same on the next flights, except we'll add another string of redundancy, because on a test flight we don't need it. But when we fly people, we'll have 3 strings. Another thing to think about is the software, which is always a challenge. If you think about the full software for flying people on the manned flight, we've written now half of that already. Half of the software is done, tested, and will fly on EFT-1. So we have more work to go to get to EM1 and EM2, but this flight, not just the launch in December, but the work that went into this design, it sets us up very well for the next flights and for eventually getting people into space. So now what I want to do is introduce Cleon Lacefield. Cleon is the Lockheed Program Manager for Orion and a big part of why we are here today, and he's going to describe more about the mission itself. Thank you.
Yeah, it's great to be here today with our vehicle getting so close to launch. And what I thought I would do today is talk a little bit about the flight tests that we're going to do with the Orion vehicle. We're calling it Exploration Flight Test 1, and this is the first high orbital flight test of the Orion spacecraft. This flight test is scheduled on December 4th of this year, and so the countdown clock that we're seeing over here is the number of days to the December 4th launch. During that flight, Orion will travel 15 times further out into space than the space station is currently today, and it's further than humans have gone, like Charlie said, in the last 40 years. So we talked about a little bit, Charlie talked about what we're getting out of the flight with the checkout of all the systems, the computers, the software, the guidance and control, the separation events, the heat shield. And as Mark said, this is the spacecraft that we will be building for the exploration missions 1 and 2 that are coming up later in this decade. This flight will be an uncrewed launch on a Delta IV Heavy. It will launch from Pad 37 at Cape Canaveral Air Force Base, and it will travel 3,600 miles beyond low Earth orbit and re-enter at approximately 20,000 miles per hour and splash down in the Pacific Ocean, where the U.S. Navy and NASA ground personnel will recover the spacecraft. The entire flight will take about 4 hours and 25 minutes. As far as the timeline goes, the launch will occur at approximately sunrise on December 4th, which is right around 8 a.m. 5.5 minutes later, the service module fairings will jettison. Those are those big white fairings that are shown right behind us. Over 6 minutes into the flight, the launch abort system is jettisoned. And about the 2-hour mark, the upper stage, second stage engine burns and raises Orion in the orbit to create the high reentry velocity. At 3 hours and 45 minutes, the crew module will separate from the service module in the upper stage. At 4 hours, 15 minutes, the crew module begins to encounter Earth's atmosphere. And at 4 hours and 20 minutes, the forward bay cover is jettisoned, allowing the chutes to deploy, which happens about 2 seconds later. At about 4 hours and 25 minutes, the vehicle splashes down into the Pacific Ocean, and it is recovered by the Navy and NASA ground operations personnel. The vehicle will be transported back here, and we will actually reuse this vehicle for an ascent abort flight test prior to EM2. And with that, I'd like to turn over the discussion to the Center Director, Mr. Bob Cabana.
Thanks, Cleon. Well, for the first time since we went to the moon, we're stacking a vehicle in this high bay that will allow us to explore beyond our home planet and one day put boots on Mars, and that's pretty darned exciting. This is a world-class manufacturing facility with a world-class team operating it. And I want to thank the state of Florida for helping to make it possible. And I commend the Lockheed Martin team on the outstanding job that they've done manufacturing and processing Orion for its flight test this December. We are well on our way to establishing a human presence in our solar system. And when we leave planet Earth to do it, we're going to be leaving from right here at the Kennedy Space Center. I couldn't be more proud of this team in what we're doing in the path that we have going forward. So to everyone, thanks for your outstanding support, and go Orion.
Okay, we're going to take questions from those here. And as a reminder for those who are going to be up at the mic, please be sure to state your name and affiliation and direct your question to a particular person if you can. And then for those watching from afar, as a reminder, you can ask your question on social media using the hashtag AskNASA. First question, go ahead, Irene.
Thanks. Irene Klotz with Reuters and Space News. For Mr. Lacefield, when is that ascent and abort test scheduled for?
The ascent abort is scheduled in 2018, and it has to happen before EM2 because it's part of the certification before we have the astronauts on board the vehicle.
Thanks. And how many capsules is Lockheed Martin currently under contract to build?
We will be building this one and 2 others.
Thanks.
Hi, Dan Billow from WESH-TV. A question for General Bolden. What year will the first astronaut climb aboard one of these ships, as far as you know? And is it a little hard to sustain momentum for a grand mission to asteroids and Mars when you're not flying people very often?
We had a conversation about that this morning with some of the young leaders here as well as the senior leadership. And it's not hard to maintain momentum among the workforce. The momentum that's difficult is among many of you, the general public, people who aren't around this every single day. In terms of the specific year that we'll actually fly, I assume that's what you mean, a human launch, is in the 2019-2020 timeframe, if I remember correctly, 2021. But we have already had humans in the spacecraft, and we've got Doug Hurley and Rex Waldheim, who are back here in the blue suits, and they're here to answer all the hard questions. But they can, I would recommend that when you have an opportunity to talk to them, ask them about what kind of training or what kind of preparation is going on in the astronaut office, how do they get prepared. So they're probably going to be the ones that tell us when they're ready to start getting fully integrated into the system itself. But the 2020, 2021 time frame is when we hope to fly the first human-rated mission. Okay?
Hi, Calorama with WKMG. Can you talk about the cameras attached so we could talk about the views that you'll get in orbit?
Yes, he can.
So we thought about that quite a bit. Some of it is so that we can share that with the public. A lot of it is for engineering data so we can see things. So we'll have cameras that watch the separation events of the fairings coming off this side, these big fairings on the side. We have cameras that'll watch the launch abort system ogive separate. We'll have cameras that watch the parachutes unfurl. We have cameras out the windows, so we'll see some of those events and probably some during entry. So we're going to have a lot of good views of this flight.
Hi, Stephen Clark with Spaceflight Now. First, for Mr. Geyer or Mr. Lacefield, can you tell us what it's going to look like inside this spacecraft when it flies on EFT-1? And I have another follow-up as well.
Yes, so this inside, it will look the avionics bay, which is where all the computers and all the cooling system will look exactly like it will look on the manned flight when we actually put people inside. But it's basically, once you come in the hatch, there's a platform that you would step onto. Below that is where the computers are attached and then connected on the inside. Eventually, when we fly people, though, there'll obviously be the seats, the other stowage areas, and then the displays and controls. On this flight, though, we do fly some what we call mass simulators. So we actually have a mass simulator for displays and control panels. So you looked in there, there'd be this metal thing that represents a display and control panel, because we need to understand in the environments we see how that mass reacts with the structure. So when we fly the real one, we know it. But obviously, it doesn't need the switches and all the other stuff that's a part of that.
And for Administrator Bolden, I wanted to get your thoughts on whether you think it's time for America to invest in a new rocket engine to replace the RD-180.
I think it's premature to think about investing in a new rocket engine. We've also been discussing this quite a bit. You know, what we encourage people to do is think about what it is you want to do. And our focus is on access to space. How do we provide routine, reliable access to space? And so if you get focused on a specific engine, you may ask yourself then, okay, what vehicle are we going to put it on? Everything else. So NASA's approach is let's focus on access to space. We've decided that for low Earth orbit, and to make a sustainable low Earth orbit infrastructure that we're going to need for the future flights of Orion on SLS to go to deep space. That's why we work with our industry partners to develop commercial crew and cargo capability, because they're the ones that are going to provide the routine access to low Earth orbit so that we have a place that we can go and come from. Our job right now is to provide the vehicle that can get us access to deep space, and that's why our focus on SLS on Orion right now. With our international partners, we continue to work with them. I think most of you know that the service module for Orion is going to be prepared by the European Space Agency. You know, Lockheed Martin, as the prime contractor for Orion, is working with them already. So we're looking at all of those kinds of things, but we're focused on access and not specific vehicles, if you will, or engines to get us there. That's not our focus right now.
James Dean, Florida Today. I think questions maybe for Mark or for whomever. It sounds like you got quite a lot of capability in this vehicle ready to go. I'm just wondering if you can discuss a little more. Why is it going to take so long to get to that first crewed flight? Is it more a function of waiting for SLS, or why does it take 7 more years minimum to get from this stage to your crew-ready vehicle?
Yeah, good question, because we got a lot on this vehicle. So in this vehicle, we do, as I mentioned, the parachutes, the structure, the heat shield. Those were big risk items. You can think of schedule risk items. But we still have a lot of work in the service module area, some of which ESA's going to do, which takes time. They just finished their PDR. We also have to work then on the rest of the ECLIS life support system, the crew displays, the crew seats, all those kind of internal things. And then the other part that is a little hard to describe, but we have a qualification program where you take the unit and you actually test it to the extremes, where you actually all your acoustics loads, all the other thermal environments. That testing program on the test unit takes time and money to do, and you want to make sure you've tested it on the ground before you actually put the people in space. So it's the combination of all those pieces and the flatline budget and some of our fixed costs that drive the schedule to the right. Does that answer your question?
Sure.
Okay.
And could you talk about what else is going to be needed to, again, get from this first crew vehicle to what other systems are going to be needed to enable a Mars-type mission? Obviously, it's not just this little capsule that's going to make that journey. How much more is needed to do a mission to Mars or land anywhere?
Good question. So Orion can fit in all these architectures. The part it provides really is providing a safe place for the crew to operate, and it gets them out of Earth orbit and then eventually back safely on the ground. So that's the part it provides. And it provides a capability to support the crew for a certain number of days. 4 people for 21 days gives you a sense. But when you're going all the way to Mars, which can be 9 months to a year one way, you're going to need a bigger HAB module, obviously, more supplies, and bigger propellant systems to do that. So that's the part that would need to be added later. Yeah, sorry. Yes.
Let me add another thing, James, that's really important to me as administrator. In order to get humans to Mars, that's hard. So we all need to agree with that. Whether you accept my statement there or not is immaterial, to be quite honest. It's hard to do this. We have to be able to guarantee that we can safely get humans through the environment of radiation and everything else. And we work with two matrices, as a matter of fact. One of them deals with the human body, with our human performance and human survival. And our matrix says that using the International Space Station as the dominant platform for development of procedures and protective devices and the like, we're probably out to 2026 before we buy down enough risk that we're willing to ethically put humans on a spacecraft and try to send them to Mars. We're probably out to 2025, 2026 from a technological perspective before we have the knowledge on the environmental system, because unlike space station, where if an ammonia pump breaks, we put it on something on a SpaceX Dragon or a Cygnus or a Progress, and we send up a component. We can't do that on the way to Mars. So I've got to give him a capability to build a much more resilient environmental control and life support system than we have today. We don't have it yet. It's in development, and a lot of it's being tested on the International Space Station. So that's the part of those of us who are here on this side of the line. We recognize the challenges we have ahead, and that's why there's not this loss of momentum that you asked about earlier. But for the outside, you want to know, okay, I see this vehicle, why can't we just put humans in it next week? Because it's not ready. We don't have all the technology that we want and need, nor do we have the knowledge that we want and need to make that trip survivable by humans. So there are a lot of gaps that have to be filled between now and then.
We're also getting a lot of good questions from social media. I've got a couple here. At Christy Marshall asks, what data will be collected during the test flight? And in a related question, at Tech Guy King asks, will the capsule carry more sensors than a normal flight? So,
yeah, for EFT-1, and we're looking at for the first 2 exploration mission vehicles. For EFT-1, we're flying 1,200 additional sensors from the nominal set that we would look at on each of our vehicles. So we're heavily instrumented in vibration, in temperatures, to make sure that we understand the environments, and all of the event timing to make sure all of the events happen when they're supposed to be happening. So we're heavily instrumented for this vehicle, and that has taken up quite a bit of the computer space. We've actually added some development flight instrumentation computers just to handle the volume of the data that we'll be receiving.
Hi, I have a question for Mr. Geyer. Is Orion still considered a backup for commercial crew? And if so, at what point in the testing program will what you need to do to prepare for a space station mission kind of diverge what you're doing for the primary goal of the spacecraft, which is to do the deep space exploration?
Let me take Mark off the hook. No. Orion is not considered a backup for commercial vehicles for a number of reasons. One is we made a commitment to industry that we would not compete with them. If we had said we're going to keep Orion as a backup, there were serious doubts as to whether industry would have made the investment at all in a commercial crew vehicle, because their assumption was, okay, if NASA's going to build a vehicle to go to low Earth orbit, what is NASA going to want to use? Naturally, they're going to want to use their own vehicle. So Orion, while it can or will be capable of going to the International Space Station, is not designed to do that, not intended to do that, and in no way do we intend to compete with our industry partners. And it's a bad, bad day when we have to send Orion to the International Space Station, because it means either we've lost each of the vehicles that was designed to do that through some accident, or they failed or something. So we don't want to have to rely on Orion to do that. It means American industry has failed. And I don't think any of us wants to see that. So get Orion going to the International Space Station out of your mind. I don't care what anybody says. That is not our intent. It's not being built that way. It would be a waste of the taxpayers' money, for me to ask Mark to configure Orion to go to the International Space Station. Just bluntly, okay?
I have a question for Colonel Cabana. Can you address the safety of Orion as a former space shuttle commander? How much safer would it be than one of the shuttles that you flew?
I'd fly on this 4-hour flight if it would get me out of a few meetings. But Orion is safe in many ways. One of the things that we looked at after Columbia, and the team here just did a phenomenal job. We were talking this morning how clean Atlantis was after it came back after the final space shuttle mission. But having the capsule up on top of the rocket, out of that debris environment, having an escape system on the capsule that can get the crew from any time from liftoff to main engine cutoff safely back to Earth with no black zones. This is going to be a much safer vehicle in the launch environment than the shuttle was. So I think the team is just doing an outstanding job, and I'd fly on it tomorrow.
Except I won't let him.
We have time for one more if there's one last question. Go ahead, James.
I'll narrow it to one. General Bolden, just in the context of the discussion about Orion as a potential backup vehicle, can you say, is NASA committed to multiple commercial crew awards coming up this summer? How many should we expect?
And let me, without getting in trouble here and trying to get into Bill Gerstenmaier's job. Bill Gerstenmaier, as the head of human exploration, is the source selection official, so I won't even venture to try to guess. Our desire is to have multiple providers. Why? Because it maintains competition, so it holds the cost down. It gives us reliability and redundancy. If we only have one U.S. provider, then we're back to where we were before, where we have shuttle and Soyuz. And we know what that's like. We don't want to be there. So our commitment is to try to have more than one provider. The budget will determine that to a great extent.
And more than one doesn't mean fractions like we've seen somewhat so far, right? I mean, it's either full or it's not, right?
You're getting into what do we call this? I don't want to go there. Let me not do that, because I don't know. I will infringe upon something that's going to get me in legal problems. But let's just say more than one provider means when we start flying humans on commercial spacecraft, like in 2017, ideally I would like to have 2 people at least who can provide transportation for our crew either today or pretty soon after that. So that's all I'm going to say, and stay out of acquisition and procurement problems. Okay, and I hope you appreciate the subtlety there. All right, yeah.
Okay, well, I would like to thank our participants for talking today, and also thank you all for joining us. You can follow Orion's progress at www.nasa.gov/Orion. And for information on all the progress we're making to send humans on the path to Mars, you can visit www.nasa.gov/exploration. Thanks.